This conference will now be recorded.
So it's been a bit since we've done, we don't have any like um, one-off agenda items for today, so I thought we could revisit RTU requirements. It's been a bit since we've touched on that, and I just want to make sure we keep that thing moving. So let me pull that up. Remember where we were at on that. I haven't had a lot of bandwidth to take a look at it since we last touched on it. Sharing.
What requirements was that, Jeff?
Sorry. The RTU requirements.
Okay.
Let's see. I'm just going to go scroll through the minutes. Okay. Let's go back to RTU requirements. All right. So I think last time the discussion was around what do we do about RTU and RTREC. So, sorry, I'm just trying to page in the context from back when we were talking about this last. July 18th, RTREC device resiliency against single points of failure, a single image being corrupted, must not prevent the device from booting. Yes. On update, if the new image is not functional, the device must continue to be operational, i.e. through fallback to an old image or golden image, not mandating which one. Okay. So RT, and we don't want to mandate machine or platform topologies as much. So this turns into an exercise of mandating properties that if any one stateful component of the platform is toast, we can still recover somehow. One of the instantiations of that is a discrete RTU component that interposes on the SPI bus. That is done. It's not the only way of doing it. And it becomes not very easy to do that when you're booting, you see. So RTU, we can scope that to the component or rather, can we presume the existence of a hierarchy here? Whatever your topology looks like, there's a hierarchy of recoverability, and something sits in the root, and that root needs to be protected. Is that a fair way of characterizing it? hearing any objections.
You know, oh, sorry, Jeff, I was talking away. Um, when we assume a hierarchy, there's always some in my mind, probably 90% of architectures could assume a recovery hierarchy, but then there's probably some flatter ones that then wouldn't conform.
Mhm.
Um,
I
that's where
agree. A platform probably does not have one single root. You maybe need like 3 components to be alive before the thing can talk.
Yeah, that's what I'm thinking when we think about hierarchy.
So what's the graph theoretic term for that kind of like a directed, like just a DAG?
I guess I never really give that much consideration, but um, yeah, probably.
Just write that down. See how it looks.
I don't even think you care that it's acyclic.
If it is cyclic, that
You may
means,
have components that can recover each other, and you only need one of them to be alive.
and either one would do.
Yeah.
That is true.
Um, I, I I don't know if trying to express the hierarchy here is useful, but maybe the different types of points in the hierarchy that we care about.
Yes. Okay.
Expressing the whole hierarchy doesn't matter because you could construct it in a bunch of different ways, but you can probably reduce it to a couple different types of nodes in those graphs, and then just describe the nodes without respect for the relationship between them.
Yeah, that's a good way to do it.
I'm adding these adjectives here just because if you have a tech in front of it, everything can be recovered. But what we care about is autonomous recovery at scale. So maybe. Does this look good, Matt? You were kind of thinking of?
I guess depends on how we're defining recovery. I would think a root node is something that cannot rely on external assistance. That may not necessarily mean it can't be recovered. But again, that's how you define recovery, right? If something has an AB image and it falls back to the B, is that a recovery or is that something else?
Hey, Jeff, when you say root node, are you referring to node in the something similar to server level or device level? Can you clarify that?
I'm not quite sure how to answer that question, but I'll just kind of elaborate what I'm like by example. Let's say that there's a platform with a BMC and a NIC, and both of those components need to be alive. Like if they're dead, then you can't reach in and fix it. So those are the root nodes.
Okay, they are basically devices with special special functions built into them.
Right. Yeah. These nodes would be. I'm considering them devices within a platform.
Okay.
Okay. So then, given this language, what would be useful here to scope RTU to say RTU is a thing which protects the root node only? We don't care about the others because they can all be recovered.
RTU should be there for each one of the device, right? Are you talking about platform level RTU, or I'm apologies if I am asking the question that may have already been asked and discussed.
No, it's fine. I guess I'm trying to think of what's useful for us to say to device vendors. Like if you make a device that plugs in at this layer, at either of these two layers, do you, or would we want that device, or would we want to impose a requirement on that vendor to say your thing must have RTU functionality? And I'm saying that as distinct from RT-rect functionality. Assuming it's in one of these two nodes, it can be recovered. And if you plug it in and there's a device above it in the hierarchy, it can recover it, and so we're fine. Do we need, on top of that, for the device to have RTU functionality to guard its, to like autonomously guard its updates? Or alternatively, are we fine with saying, you know what, just take whatever update you want? You know, you can ensure that it's signed, right? You know, if you want, don't run anything that's not signed by you. But if something lands in you that's corrupt or doesn't boot, that's okay. We can deal with it by recovery. So
So my opinion, each device must have their own root of trust for update, RTU. And there are probably going to be devices where that is not feasible. I think that's where maybe some relaxation, but still need to be secure. I think NIST SP 800-193 talks about some of those. If I remember right, they categorize those devices as symbiont devices. I think short answer it's going to be combination, I guess, right? Preferred to have individual devices to have their own RTUs, and wherever not possible, some other device can act as that device's RTU, provided it meets some of the requirements to be able to do that securely.
So I think we may have to give some optional or make this sort of optional. Right? I'm thinking that there are cases where a specific platform may want to have a single RTU for the entire platform, and that has some requirements on the devices to be able to interact with that RTU or respond to it in some fashion, right? In those kinds of platforms, they probably don't want some device that has RTU functionality that is independent from the platform, and that's whatever it wants, because they may want to coordinate, right? On the other hand, there may be cases where you want the devices to recover autonomously because of whatever environment they're running on. So I think we have to, it's hard to dictate what the behavior of the RTU is in a platform without understanding what the rest of the platform is doing.
Yeah, and I think to Alberto's point, if you imagine a platform with some devices doing stream boot, for example, then they don't need an RTU and not an RTU rec. So I think we shouldn't mandate anything. That's design decisions.
Okay, that sounds like a reason not to require anything about leaf nodes and intermediate nodes, because you know you don't know what the platform's doing internally. It can manage itself. Is there room to put requirements on root nodes and leave it up to the vendors, the platform vendors, to understand what that means? Or do we need to zoom out even further and say we're not even going to look at this structure and just say, as a platform, you must be resilient XYZ?
So
actually,
just to clarify, So when I was saying, I think we don't want to mandate having an RTU in a device, but we probably want to give guidance on requirement on if you have an RTU or if you have an RT-Rec, this is what you need to do. But at the platform level, yeah, we should allow for devices to not have either of them.
Mm-hmm.
Yeah, I wonder if we can say something about the platform, the common cases that we expect in the platform, right? Like there's a single RTU for the platform, and that has some implications on the devices. There are platforms that recover independently. There, I don't know if we can list the different use cases that matter to everybody, right? And that hopefully that'll give some guidance of what kind of device or what kind of recovery you want to put in the device.
Well, there is a separate recovery spec for devices, I believe. So this is about the root of trust for recovery. So it's more of I see it as a platform level component in many cases, and I guess in some cases where the platform is a single device, it can fall into the device. But there's not much a platform root of trust can do if PCIe device, for example, like many of them today, don't have a robust recovery story. And the thing could be, hey, bolt the Symbian device onto it, but I think respinning PCBs for standard devices is not really that easy. Well, it can be easy. It's just time consuming, and I don't know why anybody would want their device to get, if you're in a market for selling a storage device or a network controller, you don't want your customers, respinning it. You want to sell it to them and them to start, volume purchases straight away. You don't want to wait 6 months to a year while they respin the card that it sits on. So there's recovery requirements at a device level, and then there's platform, I guess, recovery, because at a device level, the recovery mechanisms alone, like if we look at the recovery specification, like having that immutable anchor in the device that I think it's like right now it looks at I2C. I think the spec is written. Maybe it was USB. I can't remember, but it looks over that interface for a payload to bootstrap it in a recovery mode. That's not very useful, of course, if a device is the platform, because something has to feed it, something on the end of that I2C. So that's where I think this RT-Rack, like what's the root at a platform level, as opposed to device requirements. So the RT, as I said, RTU could be, embodied in the device, but if it's not, there are recovery requirements on devices for it to be able to interoperate with an RTU. I think how this is written, there are different, whenever we go down, like defining something platform level, we start talking about different platform configurations, and I think that's where the leaf, intermediate, and root node, at least in my mind, as I think about it, kind of makes sense, because no matter how you compose these things, it's not a specific platform architecture, but you can be composed of many. And then if the device is the platform, then of course the device must have the RT-Rec capabilities, which is different to a discrete device, which depends on an RT-Rec. I think we need to have a delineation between them. Otherwise, we start to conflate, platform and device.
Yeah, I completely agree with you, Brian. I think platform and device level, we need to add some clarity here. And the other aspect is, at least I'm struggling, RTU and RTREC are separate, right? If you look into NIST patent 193, sort of RTU is the one orderly done thing, kind of thing. If somebody want to update code, that's what you need, and you validate the signature or whatever, and then go and apply that if it is authentic code. And recovery is the one usually triggered when the entity that validates while booting or whatever, if it detects any issue, that's where I think recovery is triggered. Or recovery can also be triggered for other reasons, right? You may have discovered something wrong in another part of the system. To be safe, you want to go and recover every one of those devices. So on the second aspect that I'm bringing up, separating completely RTU and RT-REC may simplify some of these things. Somehow I'm getting a feeling that we're trying to sort of tie those together, even though loosely here, may cause some confusion.
Would it be helpful if I don't know, I'm just going to type some stuff.
Yes, what problem are we trying to solve here? I mean, is there a problem statement? Like, is it like Brian was suggesting that, okay, there are PCI devices that say are not recoverable today? I mean, like, if we didn't do anything in this document, where would that leave us? I mean, is there, what's the problem we're trying to solve? Is it about lack of definitions, or are there just really devices or platforms that are missing something that we want to specify what's required?
Well, I mean, Brian, feel free to jump in here, but like if we were to take that kind of, okay, let's say it's the PCI device which doesn't have the recoverability lines, then all of a sudden that becomes a root node in this topology and therefore must have an RTU.
Yeah, that's kind of exactly my thought on it. So there's devices, if we come out, Matt, with just the, hey, this is how PCIe devices should be recovered, follow this recovery spec. That's great. But then what about when the device is an SoC and it's packaged on a network by itself? Where does that I2C go? So I think the definition is needed for both, like the RT rack and the device level recovery and how it interacts with the RT rack. And I think if we switch everything to being an RT rack, it becomes kind of onerous on devices where they're all trying to do autonomous recovery, which I think is not necessary. They can go back to an RTU for update and an RT rack. And it's trying to define that. I think when we don't define it, platforms and systems in the industry come in all in inconsistent. And you might say, like, I'll give you my view of the world and problem. I build a lot of 1-socket and 2-socket servers, but I don't build a whole lot of 8-socket servers. Somebody else does that, and I buy them from them. And those things come in massively inconsistent from a recovery and manageability perspective. And similarly with GPU chassis, they come in wildly inconsistent from a update recovery perspective, and getting these guidelines in place where we talk through the various kind of architectures that we see, and how they can conform to some type of consistency that they can all be adopted and interoperate in an ecosystem. And I think recovery for me is like the forgotten security property. It's the one where, hey, we've got attestation, we've got secure boot. Okay, what do we do when it's all host? Oh, then you send somebody out to it, or you send it back to us. That's really the recovery strategy. Or we got AB images. What if the signing key is compromised? Oh, does that happen? Yeah, here's some examples where it's happened in the past. I think that's why this is necessary.
How can you elaborate more on how RTU RTREC would help address signing key compromise?
This is where you've got well, it really it goes to RTREC. Like when we talk about recoverability, and hey, we've got these AB images, and we know we're really good at doing AB images, and we'll always we'll never accept a B when A is bad, and that's true for like corruption cases, but when keys get lost, that ceases to be true. Those guarantees can be bypassed. And right. Then, so that's why on the device recovery, we have that, go from that immutable anchor to be able to get the device back.
I see. Well, that kind of presumes the thing with the bad firmware signing key is not an RTREC itself, right?
Yeah. And in some cases, it's narrowing it from the many down to the one. And how we deal with these things, like the root nodes, like the leaf nodes and the intermediate nodes. They, like, if we categorize like devices in the architecture as those things, it's like, hey, can we get it down to the roots? And the recovery on the roots is a little different maybe to elsewhere.
Does anyone have an issue with these bullets? Cool. Hear no objection. So also as per this, and I think might have been, I'm not quite sure who was just this concept, but like, we're not saying you can't have an RTU anywhere else in this graph, but so you must have it here. So then, what did we write here? Properties for RTREC devices. I think we can reword that to properties enforced by RTUs. We wrote resiliency against single points of failure, single image being corrupted through bit rot must not prevent the device from booting. On update, if the new image is non-functional, the device must continue to be operational through fallback to an old image or golden image. agree with these? Is there anything else we feel like an RTU should be or enforce?
I think the second bullet really RT recovery functionality, not RTU's function, in my opinion. If something not functional, then I think RT rec should kick in, and then that's the one should take appropriate action, even at the device level or at the platform level. I'm okay to leave that in there, but it's more of a RT rec functionality.
Okay, I think I see. Yeah. What if I redid that? Because I think what we're trying to focus on is what I had intended to, or what I was thinking that these would apply to is like, what are the properties that the RTU enforces about RT-Rex? Because in that scenario, if the device is an RT-Rec, doesn't have anyone to recover it, we still care about this, and we can't just say, oh, the RT-Rec takes care of it because this is the RT-Rec itself.
So on an update or corruption or any of those situations, right? So we should have a way. We don't want device to be completely dead and sitting there. We really want some kind of recovery, either kicked in through the validation or kicked in triggered by some other entity or whatever. I think there are many ways you can trigger the recovery. It can be automated based on the condition, or it can even be manual or through some remote action.
Yeah.
Who knows? I think many possibilities.
Right. Like if the device is a leaf or intermediate node and has something to recover it, then we don't need to be as stringent, right? Recovery happens, it works, right? That's how you do it in your system. But if the device in question sits at the root node, I think the device needs to be a bit more careful about how it treats its updates, because there's no one to step in and fix things if they go wrong. There might be a way to reword this, so like, because yes, this is a thing that RT-Recs provide, but if the thing is an RT-Rec itself, then it is its own RT-Rec. But it can't really be its own RT-Rec, so that's, I think, where the RTU concept comes in. Maybe the RTU shows up in this graph as a cyclical node, like something which points back to itself. That's RTU functionality. But that might be getting a little esoteric. Does that make sense? Or do you still have concerns about this language? I'm happy to there's ways we can rephrase this. I think it's great points. I'll just move on then.
Jeff, it appears to me that lot of these things at device level clearly specified in other documents, such as NIST SP 800-193, all the requirements. It looks like we are trying to come up with what should happen at the platform level. I may be wrong, but I'm trying to figure out what we're trying to do here. Yeah, mostly that level is not specified in other documents. If you are attempting to do that, what should happen at the platform level? I think it's a good, and we are covering the potential corner cases that may not be documented anywhere else. Things like the second bullet here, an update if something fails. We don't want that device to be completely dead. Instead, we want it to be able to recover depending on the device type itself or through some other means and come up back to operation. Is my understanding correct, or am I missing something here?
Well, I think it's a good question. Like, what's the scope of this platform versus device? I was thinking this would be a device requirement that applies to things which show up in that category. And less of a requirement. Well, I guess it becomes a requirement on the platform as a whole only insofar as this graph is a property of the platform. And so what shows up in the root node depends on how you build your platform. But once you built your platform and you have your graph, anything that shows up in this position has RTU requirements, was my thinking. Is that a more or less useful way of writing things down and framing things?
So are you assuming that there may be more than one root node here, Jeff? I'm sorry, just trying to understand.
Yeah, exactly. Yeah, there might be multiple devices within the platform that, for whatever reason, can't be recovered. Like the wires don't exist to them, or basically the wires don't exist, and there's nothing sitting elsewhere that can reach in and recover it. So now we care about its ability to protect its own updates. And well, like I say, like anything can protect their own updates. Go do RTU all day long if you want, but we really care about that happening for these root nodes. So
are we clarifying or loosening or hardening the SP 800-193? SP 800-193, I know it's a guideline, but I think it assumes every device to have RTU, RTREC, RTD as well, detection, root of trust for detection. Just wondering in that context, it looks like we are adding some clarifications on top of that for platform level.
Let's look at that. RTU and chain of trust. Each platform device with mutable firmware shall rely on either a root of trust for update or a chain of trust for update, which is anchored by an RTU to authenticate firmware updates. If the RTU, sorry?
Yeah, so one other clarification here is that, that I just want to add commentary on why CTU exists here. So root of trust for update can update that root of trust code itself. I think there are different code modules can exist in any of the device, right? There will be some code is considered as root of trust, and then the other rest of the code can be updated by that root of trust. But root of RTU can be root of trust for the root of trust code itself, or it can also update the rest of the code. I think it gets a little bit convoluted, but I'll let you continue there.
Yeah, I admit I haven't really dug into this section lately. So
I think one of the problems with 800.193 is it's really, right, this applies when you have a chain of code like BIOS booting into an operating system and you have a bunch of different components and you might be switching keychains that you use to validate the next component. If you're talking about independently booting components in a platform, right? If you have like a CPU and a GPU and a smart NIC and an SSD and other things that are all loading and validating and running their own code, the CPU RTU is not validating the code that your SSD loads and starts running.
Yeah, this is the device level SP800 documents at the device level. Everywhere it says device. So for example, if you read that first point that Jeff was highlighting, each platform device is the one, these documents. I think all the devices you mentioned should have these characteristics unless it is categorized as a Symbian device. So PCI vendors probably can help us here, PCI card vendors. My understanding is some of the PCI card vendors either already implemented or working on implementing this RTU and RTREC and RTD along the line what NIST SP 800 193 was talking.
Yeah, that makes sense. And as for how this relates to this, or how this this OCP document would relate to this NIST document, perhaps we are trying to be a bit more opinionated about, like, just provide some guidance around when is CTU needed versus RTU. Because we don't like, I mean, all else being equal, we like having less roots of trust in the machine. I mean, just for a matter of complexity, right? So this gets into like why you do streaming boot. Instead of having stateful devices everywhere with everything having its own RTU, just stream boot from one stateful location and have the RTU be centralized there. So it is preferable to have that kind of platform if you can get away with it, just from a simplicity perspective.
Agree. I think NIST, as we all know, always tries to accommodate every kind of device that you can think of. That's where some relaxations, yeah, OCP can certainly go and say that, hey, this CTU doesn't look good or we don't allow or something along that line. I somehow think looking at what exists currently in the NIST 193, OCP may want to take a stand that by referring to this one, all the devices or whatever certain category of devices must support these requirements. You can point to what are there in the 193, or we can restate if that is easier for readability purposes. And then on top of it, I think we need to document what else we want, or what else we want to tighten, what else we want to relax, is the thing I was thinking. I'm not questioning any of the effort that's going on currently, but we may want to tie that a little bit tightly with this document if possible. Yeah, those are the three things: protection, detection, recovery are the things specified in this. What kind of routes are required for these, and what are the security characteristics of those routes, and what is the expected behavior is the one this document talks about.
Mm-hmm. Okay, well, I think this has been a good discussion. I'm kind of out of ideas on things to write right now. I think that this deserves some offline noodling.
Yeah, let's all read through it. I think there are probably other people as well here. As one of the contributors to this document, I can probably answer some of the background, or if you have questions on some areas of this document, I'll also be glad to sort of walk you guys through if that helps. But I think document is not that many pages, probably around 30, 35 pages, I guess. So you all can go through and see how we can tie that into this effort, or at least use that information already available and then come up with our own OCP requirements for RTU or RTREC or whatever else we think makes sense.
Okay. All right.
Yeah, I see Vincent Zimmer, I think, on this call is the other one contributor, Paul England, and I don't know Paul England participates here, but there are other people as well, right? Some of them probably chosen not to be listed here.
Sure. All right, cool. Well, let's take a look at that and reconvene. I guess we'll have 8 minutes back. Thanks all.